So I don't know if you remember spring 2020, some stuff went down, and you can talk to me about it later if you don't remember. But during that time, I was really missing going out and listening to music. I love going out and hearing bands and dancing to loud music in the middle of the night, and it's kind of taken from me for a while. So I went online to try and fill that gap, Twitch and YouTube. And what I was finding was DJs and bands getting kicked off these services. Um, Even bands playing their own music was getting hit by algorithms, which was ridiculous. And I started thinking, what what are the options for artists and creative people who aren't trying to do anything wrong? They're just trying to get their art out there. There must be some kind of independent alternative. So I looked, and there wasn't. So I figured there has to be a good reason for that. It must be impossible for normal people to run their own live streams. But I had to try it for myself. And I found out that I was wrong.
Atlantic Records issued full-blown takedowns on two streamers.
Some folks got multiple strikes this weekend.
One of them happened because a stream sniper ran up to the streamer and played like 2 seconds of a song.
He getting hit like this.
Are at risk of being permanently banned from the platform.
You're in the middle of a session and everything's going great, and all of a sudden, boom, you're off. You have no idea why.
I'd show you the clip, but I don't want to get a DMCA takedown.
It's not that I want to see YouTube go under or Twitch go under, but I want a viable goddamn competitor.
I'm Gabe. I work on Owncast. That's what a model says that I should look like. Close enough. Owncast is an open source, self-hosted live video streaming server. It aims to be self-contained, fast to get streaming, and useful out of the box. It's for individuals and organizations. It's meant to be empowering, customizable, hackable. It's your server. You should do whatever you want with it. It's a way to make your own choices about what you want to put out on the internet, but you also take responsibility for it. It's easily integrated into other pages and applications and platforms, and it's really an alternative for those who want it. It's not a competitor to anything. I tell people Owncast is as much as a competitor to Twitch as Nginx or Apache is a competitor to Facebook. It's not for building service providers. It's not encouraging copyright infringement or piracy in any way. And at the same time, it's not your babysitter. Today, we're going to talk about why you would want to host a self-hosted live stream. We're going to go deep into how video streaming on the internet works. We're going to talk about Owncast chat and social engagement features. We are going to do a demo of installing Owncast from scratch and doing a live stream with it. We will discuss the requirements for servers and networks. We'll talk about building your own custom integrations and using the APIs that Owncast offers you. We'll talk about scaling your stream because you are just that popular. And last, I will thank you for coming and invite you to talk to me later. So one day, I received an email from this father who just told me that his newborn son had just passed away. And it was deep into COVID at that point, and none of the family members or friends of this gentleman could travel to a physical funeral. And he was looking to see if there was any way he could run a virtual funeral for his friends and family. He didn't want to deal with video conferencing or sending grandparents a conference link or trying to figure out Jitsi or Zoom. He just wanted to send out a link, people click on it, and take part in this event. This was something uniquely, something that he wanted control and ownership over. He clearly didn't want to hand this off to a third-party mainstream service. This is very personal to him. And while that's a really sad story, and I hope you don't ever have a use case that is even close to that, I think it does get to the heart of why you might want to own your own content. Too many things in my hand. So what are some other use cases? You might want a private video stream that's internal to your company or organization. A one-off event, birthdays and weddings. Maybe you have an existing product and you want to add a live video stream to it. Maybe you want to go all out and build a 24/7 live media empire. Maybe you have your own authentication methods, such as single sign-on, or you have a ticketing system you want to use. Maybe you just don't like ads or your viewers being sold to data brokers. Or perhaps your use case contains content that might be like not completely aligned with the terms of service of other services. So your farming streams will have to go somewhere else. What do you think I was talking about? I asked some people who use Owncast why they like it, what they get out of it, and why they chose it. And here's a small clip of that.
Most people have given up on owning their own digital identity.
And we didn't want people to have YouTube or Twitch accounts in order to participate, and we didn't want to deal with ads interrupting that content.
We've been using Owncast for more than a year now and regard it as an important part of our infrastructure.
I've run multiple full days of conference talks using Owncast, where we're hosting workshops about various security and authentication related topics.
Owncast features functionality which is either missing in comparable software or is hidden behind a subscription model.
Just my own privacy and independence and security, but also those of my viewers.
It is wonderfully freeing and takes you away from the toxic world that is Twitch.
It allows independent creators like me to be able to create and distribute content without relying on corporate gatekeepers.
But Gabe, independent live streaming is literally impossible. There's not a week that goes by without somebody telling me that, like to my face, saying, normal people can't do this. Only big tech and huge enterprises can pull this off. But that's what they want you to believe. You know, if you rely on big tech and these huge companies, then they can monetize you. They can sell your data. They can track you. You rely on them. So I'm saying you can run your own live stream, use Owncast, you can do all this great stuff, but you're a bunch of smart people, and I don't think you should just trust me. You should take my word for it. So what we're going to do is, because they gave me 50 minutes for some reason, we're going to go deep into how live video on the internet works. So then you can believe me when I say it's not that big of a deal. So Owncast uses a form of live video streaming called HLS, or HTTP live streaming. This is different than the form of live video that you might get with Jitsi or Zoom, or like real-time conferencing type tools. We're going to start with this diagram. There's some video from a broadcaster on the left. It gets sent to Owncast. Owncast does something with it. People can watch it. So let's start from the left. You send video from your broadcasting source, such as OBS or vMix or whatever your broadcasting software is. It uses a standard called RTMP, or the Real-Time Messaging Protocol. This is very common. All the broadcasting software use it and support it. All the large big tech streaming services, they all use it. So that's why Owncast uses it. HLS, or the HTTP live streaming, is a standard that was created by Apple. Almost any live video playing software can play it, like FFmpeg or VLC or MPV. It's super common, super standardized. But the really nice thing about it is highly scalable using existing web infrastructure. And I want you to keep that in mind because we're going to come back to that later. It's stupid simple. You're going to come out of here and be like, that's it? Yeah, that's it. Use a standard HTTP. It's right there in the name. Any web server that can serve static files can serve HLS assets. The HLS assets are really just tiny segments of individual playable video that are generated on the server. The client downloads it, plays it back one after another, over and over again until the stream ends or the planet burns out. These segments are listed in order in a manifest, or what's called the playlist file. I bet you didn't expect to see that. The playlist format, and I'm not joking, this is true, is actually the same format that Nullsoft created for Winamp all those years ago, the M3U format. I don't know why, but I guess somebody at Apple was whipping the llama's ass. You get the joke? Otherwise, it's really, really stupid. There are two types of HLS playlists. There's the master playlist and the media playlist. The master playlist points to all the different media playlists. So if you think of high, medium, low quality as being different versions of the media playlist, the master playlist points to them. It will detail the bit rates, frame rates, resolution, all the details that will tell a player some information about which quality it should be playing at any given time. This allows the player to be able to switch between all these different media playlists. And this is using a technique called adaptive playback. For media playlists, each one points to all the playable video segments. And there will be multiple media playlists, one for each kind of quality that's an output. Again, if we think of high, medium, low qualities. And here's an example. On the left, we see a master playlist with 3 media playlists in it. 1, 2, 3. And over here is the media playlist for one of those. It doesn't really matter. And you can see all the .ts files that are listed there. Those are the actual playable video segments. And you can see they're just listed one after another. And this target duration 5, that means each one of those playable video segments are 5 seconds long. These video segments are commonly using a container format called transport stream. So you see the .ts files. And inside is generally encoded with H.264 video and AAC audio, but doesn't necessarily have to be. That's just kind of what you'll see the most. So here is a visualization of adaptive playback in action. So again, we're talking about the 3 qualities: high, medium, low. And on the bottom here, we have the player. And the player is moving forward in time, playing back those playable segments. So in this example, the player starts with the low quality. A lot of players will do this to get up and running and streaming faster. So it'll just download the lowest quality and kind of get up and running. And then it sees, yeah, my network is nice and fast. I'm able to download more content faster. I'm going to jump up to the medium quality. And then you see that the two green boxes, so two more segments of 3 seconds each. So it plays 6 seconds of medium quality. And then the player says, yeah, this is great. I'm able to download content nice and fast. I'm going to jump up to the high quality. And again, in this case, it plays 2 3-second segments of high quality. And then maybe you're on mobile and you go in a tunnel, or you're at home and you start downloading something and your bandwidth kind of dips. The player will detect this and move down to the medium quality, saying, oh, I can't handle the high quality anymore. I'm going to bump it down. And then maybe later it'll detect that it could go back to the high quality. If you were to open your browser dev tools while watching an HLS stream, it would look like this. You see a playlist get downloaded, and then the player will download the new segments, and then a playlist download and new segments, and over and over and over again. So there we go. Now you know how HLS video works. You can go tell your friends how easy it is. So where does Owncast come in? Remember this diagram from before? We are smarter than that now, so we can move on from this simplistic diagram and do something like this. We see that Owncast now has the role of taking the video ingest of RTMP. It will re-encode the video. It will segment it into those small playable chunks and then serve them through a web server so it can be played. The web server in Owncast's case here is actually doing more than just serving the video segments. It's also hosting all the APIs and the chat service and the web interface and all the features that Owncast offers you out of the box. And this is a good time to talk about some of those features. So while it's an oversimplification, I kind of think of live streaming in two pretty wide buckets. There's the use case where maybe there's a venue or a TV service or something where they're treating live video as just a piece of infrastructure, and they already have an audience and they're just trying to get their content delivered to that audience. And then there's the ones who want to increase their viewership. They want to engage with chat. They want social integration. They want chat bots, kind of the Twitch style of live streaming. So let's talk about Owncast chat. A popular form of streaming is focused around the streamer and chat, which I'm sure you've seen plenty of. The Owncast chat is completely optional. You can turn it off. It's meant to be super low friction, so no accounts are required. You just drop by the page and you can start chatting. I feel like if that approach is good enough for IRC, it's good enough for me. It supports moderators and being able to ban people and message removal and all the stuff you would expect to see. You can ban IP addresses, and there's built-in rate limiting and time-delayed chat participation and a bunch of niceties as a part of the Owncast chat. And optionally, if you have a Fediverse account or an IndieAuth authentication option, you can actually register your chat identity with the Owncast chat server, so then you can log back in from other devices and things like that. But most importantly, custom emojis. Here's an example of a Owncast server, some chat. You can see Mega Man and I guess Pepe. Here's another one. You can see that they changed the design and fonts and things like that. So who here is familiar with the Fediverse? Dope. Yeah, you guys are awesome. For the few uninitiated, it's a decentralized and not in the blockchain way, like set of servers and networks that can talk to each other using a shared protocol called ActivityPub, and they can talk between each other and federate. With Fediverse. We're not going to talk about how the Fediverse works, but you should go check it out. Anyway, your Owncast server can optionally be a part of the Fediverse. So what does that mean? It allows people on the Fediverse to follow an Owncast live stream, so then they get notified every time you go live or a message gets manually posted from that instance. The actions taken on the Fediverse, such as following, sharing, liking, will actually get highlighted in the Owncast interface to kind of show the biggest fans and the power users and show the outside engagement that's taking place. If you see that somebody is sharing out in the Fediverse and their name comes up, you feel kind of encouraged, maybe a little peer pressured to do it yourself. And that allows kind of using your existing social graph to share live streams to more people. Here's some examples of what that looks like in chat. Follow, share, like. Again, disabled by default. So the mindset of Owncast is it's your server, and no defaults are telling anybody about your server. Right? It's private by default. Any kind of outside integrations or engagement options, you have to turn those on because Owncast is going to, by default, assume that this server is your private server and you're going to do whatever you want with it, and it is your choice who sees it. Some people really love these features and some people don't care at all, right? If you talk about those two buckets, the wedding reception use case does not care about the Fediverse or chat. But the Twitch style cares very much about this stuff. Here's some screenshots of what Owncast on the Fediverse looks like. On the left, there is a iOS app called Tusker, and you're viewing somebody's live stream, in this case, a stream called Retro Strange TV, and it shows up as a user profile, just like if it were a real person, and it has all their Owncast metadata and links. In the middle, you can see an automated post when this live stream went live. So it has a little animated GIF there showing a couple seconds of the live stream, links and tags. And then on this side here, we show somebody actually just sharing a live stream, just posting a link to it, which actually puts the live stream embedded into a timeline. And this is Mastodon. So that means somebody can actually watch the stream from within the timeline. All right. So I told you why you might want to run your own stream, and we discussed how it works. And I told you about some of the features, and I think you're prepared. Think you're ready to go. We will demo Owncast. So what does that look like? Step one of the demo, of course, the human sacrifice to the demo god. Then we will install Owncast from scratch and stream to it. We'll check out the player and chat and the web interface. We'll visit the admin and check out some of the configuration options that you can use. But ultimately, I'll probably just end up clicking around and just showing you random stuff. So let us move on to step one, human sacrifice. No. Yeah. All right. Okay, fine. We'll skip it. But if the demo goes bad, like it's on you. All right. Now I awkwardly change display settings and main mirror. All right. What is this? Sure. All right. On the left, we have a VPS that's just on DigitalOcean. I created it just for this demo. See, I'm running as root. Don't do that. And to install Owncast, you go to the website, owncast.online. You click a button that says Get Started. And I'm not sure how the Wi-Fi and network here is going to deal with this, but we'll see. We're going to say we want to manually install Owncast ourselves. For this case, we're going to use this Owncast quick installer script. And it's a little curl to bash. And I know what you're thinking. Don't curl to bash. But if you read the script and you trust it, you can curl to bash. But read it. And I trust it because I wrote it. Uh-oh. I think the network is not happy. I will try tethering to my phone. See, yeah. So, oh, maybe not. Your fault. All right, I'm using my phone, and I think that's working. All right, we'll see how OBS and live streaming over my cell phone connection work. What's that? Oh, yeah. Good call. All right, where were we? We were curling dash. Ready? What's going on? Am I on a wrong? Oh, I think I have them. RNRF Owncast. Okay, so that was the quick installer script. It's done. It's telling us what to do next. Change to the Owncast directory, run Owncast. The default port is a default password. So we're going to do that and do that. And Owncast is running. That is it. So we can, what is the IP address of this thing? Right here. So let's go to that port 8080. And there's the web interface of Owncast. Clearly not streaming anything, but actually let's check with the admin. There we go. No stream is active. Do that. So let's open up OBS. And to where are you, OBS? All right, so we are going to change the streaming settings in OBS. So we just go to stream, we change it to custom, we type in RTMP : and then it tells you to do this in the admin, but I'm just going to skip that for right now because cool. the port is not needed. RTMP has its own default port, 1935. Yeah, no video sources. Cannot, did I make a typo? Oh, I did. There we go. Yes. Oh, is it? Am I not allowed to stream over a cell phone connection? /live. Oh, there we go. I don't know. Turn it off and turn it back on again. All right, great. All right, so OBS is now streaming to the server that we just set up. Took longer to get OBS working than it did to install Owncast. So let's drop in. Where'd my browser go? Oh, here it is. All right, so we went to the admin of Owncast and we started streaming from OBS. And we can see now a stream started 1 minute ago. There are 0 viewers. There's one outbound stream of 1200. There's audio, and here's the input that is coming into Owncast, OBS. So let us check it out. Oh, right, we didn't add anything on OBS. Audio, and here's the input that is coming into Owncast, OBS. Guess it's working. We will mute that, and we'll just, I don't know, add something. Text, sure. Hi, planet. There we go. And I'm glad somebody caught the IP address and dropped by. Who was it? All right, so we are streaming from OBS, working, looks like that. Blood for the Unix gods, accurate. Cool. So we now have 2 viewers, 100% playback health, things looking good. We can drop by the viewers screen. It starts graphing viewer counts over time. We can get details of what player clients, so Firefox and Chrome, but you could also see VLC or QuickTime or whatever you're using to play back. We can check out who's connected to chat. There are 2 users. We can ban them or make them a moderator. See, oh, look at all these. Yeah, all right. All right, you can moderate chat messages, remove them, unhide them, that kind of thing. Here's the custom emojis. You can load new ones. This is the default set you get when you install a fresh copy of Owncast. So let's drop by how you configure Owncast. The general settings are the basic things like name, description, logo. But there's also some cool stuff in here. You can set a custom offline message. So if somebody drops by your Owncast when you're not streaming, it'll give them a message. Tell them to check you out on your social links or whatever. You can turn off some features if you don't want to be indexed in search engines or you don't want the viewer count to show. There's a handful of things here. Might have noticed there is this bottom part here where it says welcome to Owncast, and this is like the default content you get. You can change that here. It's just markdown, so you can kind of easily change the content of your page pretty easily. But if you want even more customization, you go to the Appearance tab and change the colors. You can set your own CSS variables. You can hide and show and move things around to CSS. kind of do whatever you want. That's where you would put CSS. If you have some JavaScript that should be run when the page loads, like if you're bad and you want Google Analytics or something, I guess you could do that here. Here's the server setup tab, where you change the admin password. You can change the ports. There's some override values here for more advanced setups. If you want multiple stream keys, like maybe you share a server with multiple people and you want each one to have their own stream key, you can do that. And see this S3 object storage tab? We will get back to that. But this video tab is kind of where the magic happens. Earlier, we were talking about high, medium, low qualities of video. This is where you configure that. So by default, Owncast gives you a quite low bitrate output. So then you could go in here and start creating your own. Say I want, this, I want to allocate this much CPU to it. There's a bunch of other settings. You can change the resolution. You can change the frame rate. So if you want to say like my lowest quality is super low frame rate, super low resolution, you can do that. It is transcoding on the server, yes. We will talk about that. All right, so this is the video. There's chat options. This is where you can turn it off. There's some toggles for various settings. You can set certain usernames as forbidden. You don't want people logging in as admin or system or Owncast. You can change the set of default usernames. People who logged in might see that you just get automatically given a username. This is where you could configure that. We talked about the social features and the Fediverse. This is where you configure that. So you can turn it on. You can set stream name, whether you show up as not safe for work on the Fediverse. The automated message every time you go live that gets sent to all your followers. We'd put that here. And then that we were talking about how engagement, like follows, shares that happen on the Fediverse show up in Owncast. This is where you could turn that off if you want. There's some built-in notification channels. So Owncast supports browser alerts, which not that many people like, but it's there if you want it. So your browser will tell you each time that the server goes live. If you're a Discord person, you can paste in a Discord webhook, and then your Discord channel will get notified each time you go live. There's some utilities here to tell you how your CPU is doing, disk space, memory, so you can kind of keep track of the performance of your machine. Because once you start pegging out your CPU, you have a bad time. Stream health. This kind of keeps track of the players on the web interface and whether they are having any buffering or any errors. When you have multiple, again, the high, medium, low, it will keep track of which ones are being played by how many people, so you can kind of make educated guesses and decisions about how you want to configure your video. So there's these values here and logs. And we will go deeper into this integrations portion in a bit, but webhooks, access tokens, you can add custom links here that show up in the interface. But I think that is an overview of all that stuff. So let's stop OBS. And we can just stop the server and go back to our slides. All right, here we go. All right, you might have noticed the ease of installation. There was no pip or NPM or Ruby gems. It was a self-contained single binary that gets downloaded and installed. There are also one-click installs on many hosting providers, DigitalOcean, Node, Hetzner. And why is this? Why is this important? Because I believe that in order for us to kind of reclaim the internet that we know and love, we need to create more tools that are easy to install and approachable by more people. I just realized I didn't change the display back here. Stop mirroring. Oh, no, I did it wrong. Right? Yeah, okay, great. So that's my rant about installing software and how easy it should be, because it should be easier for more people. If somebody has to know what language you wrote your software in, you did something wrong. Go. So we touched upon in the admin the API section, the integrations. So one major benefit of using Owncast is being able to kind of extend it. You can build chatbots. You can alert other places when you go live. So if you have a Slack channel or something, you can write some code that lets your Slack organization know. Sure, you've seen on Twitch where people type something in chat and like stuff flies all over the screen. You do that with Owncast. If you have standalone applications that should update their state when you go live or when something happens on your Owncast server, you do that. So this is done with webhooks, which is telling an external service what happened on your server, and access tokens, which is granting some external code access to perform something on your Owncast server. So this is what it looks like when you configure that. You put in a URL. It sends actions when certain things happen. So when you go live, when someone joins chat, when someone sends a chat message. Creating an access token. So this access token is giving access to somebody to send chat messages. Here's a handful of examples of things people have built in the past. And actually that emoji wall, they made a little demo clip. So I'll just show you that in action.
The input field pastes the URL you've copied from the small.stream website. Make sure you check the box which says, when a user sends a chat message. Finally, save the webhook config by clicking the OK button. And we're done. Took us 1 minute 45 seconds. Now all email.
So now to answer your question. So I've alluded to the fact that most people can run Owncast on a variety of different environments, VPSs, that kind of thing. I get a lot of really commonly asked questions like, how many viewers can watch my stream? How much bandwidth is required? How much CPU do I need? Right? These are probably very common questions. The problem with these questions are they are bad questions, and I cannot answer them for you. Why do you think that is? Yes. Like a lot of things, it depends. How many viewers can watch? I don't know. It depends on how you configured Owncast and what your output qualities are. How big is this content that you're sending out? How much of it? How much bandwidth do you need? I don't know. How many viewers are concurrently watching? How big are these files? How much CPU do you need? I don't know. It depends on how you configured your output and how much encoding work is required. More work requires more CPU. I apologize that is not a very good answer, but I hope it makes sense why I can't like make blanket statements about exactly like what your use case is. But maybe I can give some rough guidelines. People often think that more viewers requires more CPU, and that's not true. If you think of kind of how this works, we went over how HLS works. It has an encoding step, and you don't have to re-encode for each person. You encode once, and then multiple people download that content. So regardless if you have 1 or 1,000 viewers, you're essentially using the same amount of CPU. If you use more CPU and you start adding lower qualities, then you're actually going to reduce your bandwidth usage a little bit, because not all of the viewers are trying to download the highest quality anymore. And the user experience actually goes up then, because then the people with slower networks aren't sitting there buffering and getting errors trying to download the super high res copy of that video that it can't pull down. So it's really all about trade-offs. But you have to keep in mind, it's about the viewers. It's not about your CPU. If your viewers can't actually stream your content, then why do it? So we talked about configuration, resource usage, but what happens if your stream gets super popular and you need to kind of scale out to more viewers, or you want to geographically grow to a wider audience? So here's a quick question. What are 2 ways that you would normally do something like this to kind of reduce load and speed up the transfer of things from a web server? Yeah, what's that? In this case, the correct answers, because I made them, are object storage and CDNs. Owncast has built-in object storage support. So what does that mean? It means that instead of these files getting distributed from your web server, they get uploaded to an object storage bucket, and then your viewers pull them directly from there. So then your bandwidth requirements all of a sudden become very, very small. And I've seen people run very successful live streams from their homes or small network environments because they can do this. With CDNs, if you ever used a CDN, this is not anything crazy. You can put a CDN in front of your web server, and then the viewers get cached and geographically redundant content. This isn't terribly useful unless you have a lot of viewers, because if you don't have many viewers, then the requests are probably going to always get back to your web server, which kind of defeats the point of the whole thing. But there is a third option, just that one, which is the object storage and CDN, right? When you get real crazy. You upload to object storage, and then you put a CDN in front of that, and your viewers get the cached and redundant and geographically distributed version. And again, nothing is then getting pulled from your actual Owncast server. But most people don't have to care about any of this. You can get as crazy and complex as you like, just like you could with any other web server. It's standard HTTP after all. But most people just do this. Maybe you're not a streamer and you sat through this anyway. Directory.owncast online. You can check out some examples of what Owncast is being used for. It's an optional toggle that Owncast streamers can turn on to get shown in this directory. It's pretty fun to check out every once in a while just to see what weird and creative stuff is there. I take no responsibility for what you might find, however. And streams that show up there often get automatically shared to other social channels and other things that Owncast is doing. And here's a screenshot of the directory. And I mentioned other applications. Owncast will be coming out with an iOS and tvOS app soon, thanks to some approvals by Apple. And this is what Owncast looks like on tvOS and iOS. And yes, I would like to make an Android version. I know what you're thinking. Owncast is completely volunteer run project. It is just a bunch of people who contribute and donate and star and fork and try to help out where they can. If any of this was interesting to you and you think that you might want to take part, you absolutely can. This is, it's a duocracy. So we're done. Let's talk about what we went over. We talked about how you can run your own farming streams. That video streaming is actually pretty simple. And that whips the llama's ass. That HLS is built on existing web infrastructure. Apparently, the human sacrifice is optional, but highly encouraged. The resource usage and requirements for running a live stream is directly connected to your requirements and configuration. The chat and social features help you engage with and grow your audience and make your community grow. And there are options when you want to scale up to many more viewers and geographically distribute your content. Thanks.
Questions?
Oh, we have time for questions. You were first.
That was a great talk. That was a great talk. Thank you for that. What do you have in mind for future features and development for Owncast?
Yeah, so the two big features that are on the roadmap right now are replays / clips. So allow people to play a stream that already happened. Right now, it's completely ephemeral. The stream comes and goes, and it's off to the ether. But really looking forward for people to be able to rewatch streams that already happened and then create clips of little parts that were super cool. And the second thing I'm really excited about is scheduled events, because once you have a calendar and you know things are going to happen at a certain time, you have kind of all these data points to provide more actions and context. So you can go to the page and it says live stream in 1 hour and it has a little countdown, or maybe it'll post to the Fediverse and say, you know, come in 15 minutes, the stream is about to start. So you can kind of automate all these kind of engagement points. Not to mention just being able to go to an Owncast stream and seeing a calendar of when a stream is happening would be very nice. So those are the two major features that I'm really looking forward to.
Thank you for the talk. But in one of the graphs, I saw that as the number of viewers increase, your bandwidth requirements also increases linearly. So I was asking why not use something like UDP multicast, where your bandwidth will not scale linearly with your viewer count.
Yes. So the reason why, and there are other versions of this question, like why not use P2P? Why not? Right. It's because that is not. It doesn't use standard web infrastructure, and it is not a standard for players. So one of the goals of Owncast is to be highly compatible, to be played pretty much anywhere, different video players and different web interfaces and things like that. And when you start having deviations from that, then it becomes like something specific to Owncast, and then it's no longer a piece of standardized infrastructure. It requires its own player. I mean, Owncast does come with its own player, but you don't need to use it. In that case, you would kind of need these features and functionality around it just to play back the content. So that's why, while HLS is probably not the most efficient thing in the world, it is highly standardized and is scalable.
Thanks for the great talk on the project. So I had a couple questions about mainly
is it possible to put Owncast behind an Nginx reverse proxy and have it pass the real IPs of the visitors through Nginx, like receive those and use those as well? Because with Icecast, for example, if you do put it behind a proxy, then you don't get the real IP. So you can't really like ban people, for example, effectively if you need to.
Yeah. So one of the steps that are encouraged is to absolutely put Owncast behind a reverse proxy. And we don't care which one. We have some guides on the website, Nginx, Caddy, Apache, because of SSL termination. So we're not doing that internally to Owncast. We probably will at some point, but the idea is like, if you already have your own reverse proxy set up, you can quickly add Owncast to it, and no big deal. But we do use the X-forwarded4 HTTP header to get hopefully the accurate IP address of what was passed there, and that's kind of as close as you can get. Is trust the proxy, and hopefully it knows the truth and is handing it off to you. But yeah, it's a good question. It does make things difficult.
Sure, thank you. And another quick question. Does the web interface work at all without JavaScript, or like parts of the web interface? Because I know at least for some of the streams that I run, there are some people who are interested in just viewing it without JavaScript in the browser still. I know you could do it with like MPV as the browser, but I was also curious about that.
Yeah, no, this is a beast. This is so much JavaScript.
Okay, thanks.
Okay, so is that gonna be is it okay? Okay, fine. So that's gonna be a little bit bad question, but I still gonna ask it. So of course, system resources depend on the configuration and need for the server, but to which extent can the Owncast be optimized? So even if it doesn't really make much sense to run with these specs, like, can I host it on a 10-year-old laptop or a Raspberry Pi or something like very low end? To which extent?
No, that's actually a good question. So there are options. And if you're running this on a VPS, you have fewer options because you don't have any specific hardware. But if for some reason, like if you want to run it from home on a Raspberry Pi, we do take advantage of Raspberry Pi hardware encoding, which actually makes the Raspberry Pi far more efficient at encoding video than like a CPU encoding task would be. Like it's pretty impressive. We also support NVENC, so NVIDIA hardware accelerated decoding, Intel QuickSync, VAPI. So kind of all those hardware accelerated options. So in that case, if you have that hardware, you can take that responsibility from the CPU and give it to a GPU and actually be very, very efficient. But most people can't do that on a $5, $10 VPS on Linode or whatever.
Yeah. So what's the typical latency or delay, say, from OBS till the final viewer?
Yeah, good question. There is an option or a setting in the admin. It's called the latency buffer. And you can set it really low. You can set it really high. So why would you set it really high? Essentially, the latency buffer is configuring the size of the segments. And the reason that matters is when you start playing a stream for the first time, the player needs to kind of buffer up a number of playable segments before it'll start rendering them to the screen. So the longer each one of those segments is, the more latency you're starting with right out of the gate. So sometimes that really matters. Like if you have interactive chat or things like that. But if you have like a TV station, you can turn that to a higher latency, and then you kind of get a little more resilience to errors. The smaller the segment, essentially the narrower the window of, like if you have a network blip or something, or it has to retry on a segment, the window of being able to pull that off before the buffering spinner starts happening is smaller. So if you have larger segments, you kind of have more video to play with, even if things kind of get flaky on the back end for a moment. It would be able to be a little more resilient to that. So that's why you would, in some cases, want more latency than less, but it's an option in the admin. You can choose that. So number-wise, I've seen people get it down to like 3 seconds. I think that's pretty rare. I think more like 10 seconds out of the box is pretty common. Great. Good questions, everyone. Thanks for coming.